We're out here in Newmont Dunes doing a burn test on lithium-ion batteries. We took one cell block from a Tesla EV. We ignited it through heat.
Thermal runaway is going to start with one cell. Whatever it's touching is going to ignite next. And then whatever those two are touching are going to spread from there. It's just like a brush fire.
It was popping off everywhere. You have to understand in a battery that not all the cells are going to go off at one time. So it's like a progression. It starts at one point and then it progresses from that point. Going into thermal runaway, the SEI membrane against the anode is going to start to decompose. So the temperature is going to go up and up and up. So you're going to create even more heat. And once you reach about 130 degrees Fahrenheit, so that's when we start seeing the pressure in the cells going off, and we're going to start seeing the batteries popping off. And then the last thing to go is really the cathodes, and the cathodes being metal oxide, it creates its own oxygen and it's fueling the whole field. We stopped the thermal event within the electrolyte before we get to that point. We extinguished and we didn't have any smoke coming out of the cells, which is a sign of more thermal runaway. We just had water vapor going out.
So prior to moving or towing a vehicle, we have another product to prevent any further thermal runaway due to the bouncing of the tow truck or the movement of the vehicle just to get it up on the flatbed.
We applied thermal shield to be able to isolate and insulate for transport. So you don't have any risk of reignition, because the problem in those battery cells is when you have a failure, whatever failure it is, some other cell could be affected but not going off yet. And with transport, it can create another thermal event and start the fire again.